In this chapter, we will learn how to plot geospatial data using ggplot2 package. It includes three easy steps. First, get the map using getMap function from ggmap package. ggmap package makes it easy to retrieve raster map tiles from popular online mapping services like Google Maps, Stamen Maps, or OpenStreetMap, OSM in short. Second is plot the map using ggmap. Finally, use ggplot2's geometrical objects like p plus gom underscore point, gom density 2D to plot the underlying dataset. Let's understand this with the help of an example. Install the relevant packages like Lubricated, grapl, ggplot2 to plot the underlying geometrical objects, ggmap to get and plot the map, dplyr to filter the dataset. Load two sample datasets, one having crime data and other the dangerous places. Let me show you both the dataset. View crimes dn here and dn here. Use attach function so that we don't have to refer each time we call the column names. Now we will extract the data of the year to analyze a manageable time frame. So format the date column using Lubricated, then extract the years to filter 2017-18 data using dplyr. Add rank and location data in a new column label in the DN dataset, which we will use the column afterwards. Our initial data prep stage is complete. Now our next step will be to get the map using the getMap and save it in an R object. Zoom here refers an integer to magnify from 10 continent to 21 building. However, the default value is set to 10. Scale is the map's resolution. Source refers to the path to download the map. And the map type is the type of the map that we want to download. In step 2, we can plot the map using ggmap function or else save it in an R object P. Now add this P with the ggplot2 objects where data is equal to C2. AES, X and Y axis are the longitude and the latitude. We will differentiate the data using initial type group color with size of the data points is equal to 3. Add a legend for a reference. In the last map, it looks a bit dirty because of all the data points are sitting on top of each other. Now, what we can do, we will filter out the topmost dangerous crimes. Now again, we will redo the plot only for important crimes with alpha 0.4 to make the points transparent. From the second dataset, we have the list of most dangerous neighborhood, which in turn will help us to understand the types of crimes for each neighborhood. We can do this by adding another GeoM point layer on top of the existing plot to plot the second dataset values. And to differentiate from the existing plot, we will use shapes for plotting each value of the second dataset. Hence, we will use the scale shape manual function to plot more than default 6 shapes. Now, in the previous plot, we can observe that there is hardly any space left for any other legends. So, to free some space for our future legends, we will simply change the shape-based neighborhood identifiers to labels. Labeling is a bit difficult when it comes in using two different datasets within the same plot. And we might face labels overlapping or sitting on top of each other. This means we have to use some other functions than geom_text. For this example, we'll use geom_label_REPL function, creating rank labels in the DN dataset, which we already did in our previous slides. Now we'll plot both the datasets C2 important and DN, then geom_label_REPL. Alternatively, we can also plot the density of the data for each events by using statDensity2D function and get the same results like geom point function. Add a density line to highlight the density estimate using GeoM Density 2D. Again, there's another way to highlight the most occurred crime types is by using facet wrap function. Filter the data with the most occurred crime types, then apply facet wrap the column name event clearance group. Finally, polish the plot by adding some details like GeoM point, scale shape manual. So far, in this module, we have learned almost all the techniques to manipulate data and perform analysis using R. In our next module, I'll take you through an advanced analysis using machine learning algorithms to predict the occurrence of an event with 99% accuracy. So see you in the next module. Thank you.